All right. Hey, it's Alex Williams of the New Stack here today for a special live stream. We're lucky to have with us Rob Zuber of CircleCI, the CTO there. Hey, Rob, how are you?
I'm good, Alex. How are you?
Great. And I had a discussion with Rob a few weeks ago, and we started talking about the technical architecture of CircleCI. We just didn't have enough time to really discuss it in detail as much as I'd like. So I'm going to spend the next, 15 minutes or so talking with Rob about their technical architecture. And Rob, why don't we just start by telling us a little bit about CircleCI and who you are and what you do?
Yeah, for sure. So CircleCI is a continuous integration, continuous deployment or delivery platform. We offer that service both in a hosted environment, cloud offering, if you will, and as a server install version, so you can take it and run it yourself. So that's part of the technical constraint of how we build. And so we sit within the delivery, within the stack, the delivery pipeline of many other software companies as they work to move faster and get their own products into production. And so we do this for everybody from small tech startups to large Fortune 500 tech companies, and really focus on helping those teams again get their product through the pipeline and into production in front of their customers faster and deliver value at the fastest possible rate.
So you talk about, shipping code faster. Tell us about how you have developed your own technical architecture. Maybe you could start with the infrastructure itself. What infrastructure are you using, and tell us a little bit about how you are maximizing it.
Yeah, so there are places all over our technical infrastructure where choices we make are designed around software delivery for sure, and that can be all the way from the very bottom where we're using a cloud environment. We're mostly deployed in AWS. We use some pieces of Google Cloud Platform, and just having the flexibility around scaling up and down, deploying servers quickly, treating that infrastructure as immutable in the sense that when we want to make a change, we just replace the piece that's in existence, either because we replace an entire VM or we replace a Docker container running on top of that VM. Really thinking about disposable pieces of architecture, if you will, allows us to move quickly and not have to worry about the state of things as they are today. And then all the way up to the top, and this hasn't always been the case, but as we talked about in our last conversation, we recently went through a significant re-platforming, redesign of major pieces of our architecture. And in doing that, we were very focused on optimizing for delivery. And a big part of that was around breaking things down into smaller pieces. Where 5-6 years ago, we were a startup too, and didn't really know whether this was a business that was going to work. And so we focused on building the simplest possible architecture, very monolithic, very focused on just iterating quickly in terms of what is our feature set even. But now we operate at a very large scale. We run a little over 6 million builds a month on our platform. And so we need to worry about operational characteristics, but also delivering quickly in a much larger environment.
Right.
And so we've taken some time to break some things down into microservices. I mentioned moving some things into Docker containers. So focusing on some current trends that really are helping people transition their software to continued fast delivery, I guess, but at larger scale.
Great. So 5 or 6 years ago, tell us about what you started with.
Well, so to be clear, I wasn't actually at CircleCI 5 or 6 years ago. I joined in about mid 2014.
So what was it like when you joined in 2014?
Yeah, so the architecture was very monolithic, as I mentioned. So single piece of software, obviously many instances of that piece of software.
What software?
Of our software.
Oh, it's your software, obviously, right?
Yeah. Our actual application, which is
Right.
written in Clojure. We're still predominantly a Clojure
Okay.
shop, even as we break things up into services. Mostly Mongo in the back end, even then running entirely in AWS. I think we've been AWS from the get-go. So very, at least fluid environment, but very focused on immutable infrastructure. So deploying something, and then when we want to make a change, instead of trying to identify what's the current state and how can we change it to another state, just throw that one out and put another one in its place. But getting to the point where there were a number of parts of that application that weren't necessarily directly tied to each other because they were doing very different things, but had some unfortunate coupling, right? Which is what happens with monoliths as you grow them over time. And we were soon after that, sort of into 2015, starting to reach a scale where the operational characteristics of that monolith started to show themselves.
Like what?
Specifically, large numbers of instances trying to do the same thing, and to personify it a little bit, sort of arguing over who was going to get to do it, and therefore causing queue thrashing and things like that. That led to us, as we tried to add more capacity from the physical hardware perspective, actually reducing our overall ability to run jobs. That's where we started to see that being able to scale in different modes for the different sort of components of what we did would be valuable. And I talk about migration of microservices all the time. You don't want to be doing it at a time when you don't really understand your business. But at this point, it was very clear that CircleCI had was a going concern as a business. We had a clear picture of what our model was, how people were using the platform, and we needed to start thinking about how we could scale it to another level.
Right. And so you were having these issues, with when you arrived, you guys were using AWS, but you were basically had a monolith technology, and and the patterns that you started to see were issues about kind of just, I don't know if it's performance issue, but it seemed mostly where you were having, where there was like so many jobs running that you started to have some crossover, and there was some confusion and kind of in the architecture itself.
Yeah, exactly. Again, a large number of instances. We had to write logic, obviously, in the early days to prevent multiple instances from doing the same thing that was only meant to be done once. But it was a very simple implementation because you're trying not to build a very complex distributed system out of the gate.
Right.
But we started to reach the point where those types of tools break down, and so I had to really rethink how to get to the next level. And our first steps were very incremental, meaning let's just tell this version, this instance to only do this subset of the work, and we'll tell this instance over here to do this other subset of the work, which allowed us to avoid, rewriting a bunch of things, but and sort of give us some breathing room to really think about how things should be architected. And so it was into, I guess, late 2015 as we started to think about, okay, what is the real kind of next version of this look like?
So what were you thinking about in that next version, and what did you have to replace to get that next version?
Yeah, so there were
what architectural decisions were what were some of the key architectural decisions you had to make?
Yeah, so some probably seemed obvious. Like, again, we had started to pull apart what this monolith did and have it run in different ways. So actually just saying, okay, don't have all of this code, just be a small service that does this thing. So moving some things to services was a small piece. From a very fundamental build execution, I mean, at the end of the day, what we care about most is how we execute these jobs. There were a couple of key tenets. One, things were very tightly coupled in terms of, again, being like, because of the monolithic model, we had a central system, or for any given job, which might be very highly parallelized, there'd be one central component owning all of the tasks that were happening and needing to have communication back and forth between each of the sort of individual tasks back to that central component. So decoupling that a little bit, breaking it apart, using a lot more asynchronous communication, so that things were just more robust, honestly. As we reached higher and higher scale, the more we depended on synchronous communication across networks that are going across different availability zones in different regions. You can't just bank on that being stable, right? So really becoming more resilient to those kinds of issues, and decentralizing work. So pushing the work down into the instances where it was happening and then just reporting back in an asynchronous manner. So structurally, that was a big difference.
What services did you start to adopt to do that?
Well, so a key piece was moving to more of an agent model. So your build is being executed by a local piece of software that's then reporting back versus again, a central piece talking out to the location
Right.
where your build is going to be run and issuing commands and sort of streaming back data.
Right.
That was a big thing. And then the other thing, to the point of services specifically, another core focus was writing less software, honestly, saying, okay, in 2011, we needed to build a job scheduler because there wasn't really a good job scheduler out there. It's 2015, 2016, whatever. There's probably a pretty good one out there that we can choose from. In fact, there's many that we can choose between. So let's go look at those and see how they would work in our environment. And to be specific, we looked at Mesos, we looked at Kubernetes, we looked at Nomad, even some of the early Docker tooling wasn't really there yet in terms of doing job scheduling. And for the actual scheduling of our arbitrary builds, we found that Nomad, which is a HashiCorp product, was very good at that piece, right? It was flexible in terms of how we could tell it what exactly we wanted to run. And it was just very fast at finding capacity in our system to run these arbitrary jobs. We wrote a little bit recently on this, but we actually then said, okay, well, we're moving all these things into services, we're wrapping them up in Docker, we need to schedule those, our services, our software, and we use Kubernetes for that. And it's kind of a long story about how we decided to use those two different things. But in both cases, it was a matter of, let's find something out there that's really great instead of writing, more things ourselves. So the core of our business is really worrying about people's builds and their deploys, and we have a lot of our own logic around that. Let's not go build things that other teams have already built really well.
So so you still use Nomad.
We do.
And you use Kubernetes, and you're using Nomad for the job scheduler. And what did you say Kubernetes is specifically being applied toward?
So Kubernetes we use to manage our own infrastructure. So as we've built out this microservice infrastructure, we have a bunch of different components. They all need to talk to each other, or some need to talk to some, whatever, roughly. And we need to say, okay, we need this many of this service, and it needs to be available, publicly, or they need to have connections to each other on these ports. So that's how we use Kubernetes to manage effectively our internal infrastructure. We use Nomad to schedule the actual jobs that we get from our customers. So I've pushed code up to a repo, and that's going to execute a build, test, maybe deploy sequence, and what we call a workflow. So effectively the steps, and some of them will be a single job, and then the dependency of that might be 2 or 3 jobs, each running in parallel. So we orchestrate that together, and we hand those jobs off to Nomad and say, this particular job needs these containers as underlying infrastructure. It needs this much hardware resource, and that's always, and it needs to be run now. And Nomad finds that capacity within our overall infrastructure, and the optimal placement of it, and executes that job, and then we collect the output from that, and then we'll run the next job.
So you find that Nomad really is optimized for finding that that extra capacity, which is critical when you're running any number of jobs and you're scaling the number of jobs that you do.
Right, exactly. So that is, and they're much more arbitrary. Like, we know exactly what our own services look like, and they're long running. We're saying, okay, we need X number of web services, or it's web servers, and they're always up. Right? Maybe we scale them down overnight or whatever, but they're basically always just running. And if one disappears, replace it. That's what, or like this box fails, Kubernetes will find some, but maybe it takes a minute or two to put the next one in place somewhere else. That's fine because there's so much redundancy there. But as far as us executing the builds, effectively, the jobs of our customers, their expectation is that I've pushed this code, it needs to be running a build now. And so finding that sort of arbitrary capacity and slotting it in and maximizing our utilization of our own resources there is where Nomad has really done a good job.
So in 2015, Docker was really starting to become much more well recognized, and the container technology movement, so to speak, was really starting to ramp up. What was it that prompted your decision to start looking at Docker?
I think it was an ongoing level of awareness over time. So the original 1.0 infrastructure, we used LXC as the build environment. So
Okay.
when we were executing another customer's job, we would put it inside of an LXC container.
Mm-hmm.
So we were at least familiar with the model of containers from the perspective of isolation,
Mm-hmm.
job execution, et cetera. But we weren't really using it for our own stuff. We would just spin up an AMI, and when we wanted to replace it, we would throw out that AMI and spin up another one. But then, we started to have customers who were building Docker containers and using it within our build infrastructure. So we were familiar with it because we needed to be able to support that. And then it became so prevalent within our own customer base that we knew we needed to make it a sort of a first-class citizen of how our build infrastructure worked. And so we moved from LXC to Docker in this new version. A big part of that was just that many of our customers have custom defined images that they want to use as the base for their build. I mean, they know exactly how this thing is supposed to run. They know what the underlying image is supposed to be. So giving them access to that as a core part of how their build runs was really valuable. And through all of our exposure, because this is one of the things about being responsible for other people's software development is you see how everyone out there is building software, right? Exposed to a really large ecosystem or a really large cross-cutting view, I guess, of the ecosystem. And so we saw the leverage that a lot of our customers were getting, and we said, okay, this is clearly the direction that the market is heading in general. We've always believed in this immutable model. We've just done it at a larger level by replacing entire AMIs. And so we started to shift a few of our pieces over. And that was more like, how is this going to work for us from our own infrastructure perspective? And we just had success with it. It worked really well. Our own ability to, build and validate and package those images and then use those to push out into production worked well. And so we just started to grow that out from there.
So, so you were looking at Docker, then and you went into this transition and started thinking about how to, take apart this monolith. You were looking at, built your own job schedule. I imagine that's a story in itself. You chose Nomad, and for the capacity reasons. Why did you choose Kubernetes? What was it about Kubernetes that you saw as really as something that really would be of value to your organization?
Yeah, so we definitely have. I mean, as you can imagine, this was a long conversation.
Yeah.
Right? We're choosing two job schedulers. We're definitely getting rid of our own, but instead of replacing with one, we're choosing two. And they're just very like our requirements were very, very different for each of those two roles. And so in terms of managing our own infrastructure, what mattered to us was the ecosystem was one big thing, right? Kubernetes is a scheduler, but with it come all of these tools that other people have built in order to help us do this job.
Mm-hmm.
And again, going back to this core tenet of let's write less of our own software and just use great tools that are out there. It was becoming pretty clear that Kubernetes was a leader in terms of the amount of community support that it was getting. And we also had a decent amount of experience with it with some of the folks in the team who were building this out. So that's valuable when you're trying to get things done quickly. And I would say, from that leadership position, one of the things I've been joking about recently is I get these constant emails of other scheduler environments saying, now we support Kubernetes natively, DockerCon Europe, there was just this big announcement of native Kubernetes support. I'm going to misquote this, but somewhere between Mesosphere and DCOS, there's, Kubernetes support now on top.
Yeah.
So it definitely is feeling like everybody's making this bet one way or another. So if you're going to...
You're not going to get fired for choosing Kubernetes.
Yeah, exactly. And so it brought the things we needed from an ecosystem perspective, and it feels like now it's being validated as we see more and more really large-scale teams.
So your infrastructure is mainly on AWS. Are you managing Kubernetes on AWS then?
We are, yeah. So we manage that ourselves over top of it.
How has that been? Because I know it's not officially supported by AWS. Has it been a
Yes.
challenge to keep it managed on Kubernetes on AWS, or is it really not, or has it really been pretty straightforward?
Yeah, I would say that there's some niceties that we don't get, because it's not sort of baked into the platform. But as I
Right.
mentioned previously, we also have a server installed of our
Right.
product, and so we actually don't, for all that we use various cloud environments, we tend to use the quote unquote bare metal. I mean, as low as you can
Right.
get. We have to think about it in that environment because we want to be able to take our product and deploy it somewhere else.
Mm-hmm.
So we don't use a lot of the higher level services anyway.
I see.
We need to be able to say, here's the entire package, and you can go deploy it. So we always maintain that separation. And because we had also, as I mentioned, some folks on the team who are pretty familiar with Kubernetes. I mean, honestly, I can't tell you about the trials and tribulations of when we
Yeah.
first got it.
Sure. Sure.
Someone else said, "Don't worry, I got this."
Yeah.
And
They know what they're
and then we
doing.
were off to the races. Yeah. So it's been fine.
Great. So, you help companies with continuous integration and continuous delivery. What did you do to optimize your infrastructure to make your continuous integration, your continuous delivery, world class?
Yeah, so I would say that the biggest thing in terms of our own changes would be around, code management, moving from a very large monolithic infrastructure to smaller pieces, and in particular because as your monolith grows, and it's not just us. Again, we get to see how everyone else is working. As your monolith grows, your test suite grows. The amount of work that you have to do to ship a change just gets bigger and bigger and bigger. And that starts to degrade your ability to deliver continuously, right? Where every change means revalidating a bunch of stuff that is unrelated to the piece that you're working on. So that had a big impact, right? And we definitely see the velocity difference as we use services versus, of course, we still have this monolith. It's smaller, but it's still there and still does a decent chunk of work. And then honestly, the container piece, right? So instead of having to spin down a machine and spin up another machine in its place, I mean, a Docker role, we actually, before we used Kubernetes, we used ECS, so EC2 Container Service, which is built in
Right.
AWS. That was kind of our first foray into a chunk of work being managed by as containers. And the ability to just say, you know what, we want 80% of the total capacity at all times online. Here's a new image, do what you will. And the velocity at which that role would then occur without anyone, needing to do anything or us to build software that specifically managed bringing up and down pieces. So one, you just roll faster. You don't have to spin up a whole new box. You're just replacing images in place. And two, honestly, moving more of that work. Like if we are not building the tooling to spin things up and down, but instead just building the business logic of our own product, then we're going to deliver faster because more of our engineers are focused on our core product offering.
Okay. So now, what are some of the tools you're using to manage that code? What are some of the the technologies that you guys have been adopting to really, because you talk a lot about saying you want to use other people's tools for the job that they do.
Mm-hmm. So in terms of managing, so I guess there's pieces within our infrastructure. We talked about Nomad,
Right.
Which is actually kind of a core piece
Yeah.
of our business logic. Kubernetes around
Right.
that. We certainly haven't written our own databases, so we use Mongo, we use Postgres,
Right.
We use Redis for some caching and things like that. And then in terms of the actual pipeline and delivery, I mean, we start with GitHub, but we obviously use CircleCI to deliver CircleCI.
Right.
So we execute everything within our own environment, and then we are pushing those Docker containers. So our images that we built out through Kubernetes. We use ECR. We use some ECR, which is the EC2 container registry, and we use some Docker Hub. Kind of depends on the specific scenario.
Okay.
There's a lot of pieces through that chain that are other people's either components or services, and then on the back end, in particular, we use Datadog to monitor. We use Rollbar for exception handling or exception monitoring, and then Let me think. There are a lot of some of those are
Yeah.
that wasn't new. It's not like we ever had built our own exception handling system or something
Right.
like that. But so those we've been working with for a long time. But it was more kind of in the core that we started pulling things out. Kubernetes being a big one, and Nomad.
So now you have platform 2.0. Where do you want to take it from here? Where is it? What is the next kind of like iteration of your own architecture that you're starting to think about?
Yeah, so that's a great question. I mean, I often joke that replatforming is not to be taken lightly. It's never something that anyone gets excited about, and we worked really hard at finding a way to get there incrementally, even as we started working on this on the side. With one, figuring out how to allow it to not interrupt existing customers. Two, how to get validation really early. And so when we think about the next steps, we don't necessarily think about 3.0. That would not be something we'd be excited about, but rather, what are the incremental pieces that we can add now? A good chunk of that is just continuing this evolution. So moving some things that today still exist in our monolith out into their own services, so they're just very clearly managed and they get those same advantages. And then really focusing on things that are more apparently customer facing. It's interesting for us. We run a service that's very it is very technical. It's very almost raw in terms of, as a customer, I'm getting exposed to the compute power and performance and things like that. So exposing this stuff through changes in architecture is really valuable. But a lot of the work that we're focused on now is around things like our workflow capability that we built on top of 2.0. So that would have been really hard to build in our original architecture. But now it's not so much an architectural change as it is just a much more powerful way for people to express the work they're doing on top of CircleCI. So new iterations on top of that, which we're sort of putting out at a much more consistent pace rather than these big architectural projects.
Interesting. It's almost like, when you get to that point where you have that new platform, and in your case is there's a lot of been thinking going on into how do you use containers and how do you use these job schedulers and how you use environments like Kubernetes. Then it's just a matter, it seems like, in some respect, like, okay, now we've done this, now we gotta grow with it, right? We can't, now it's just time to kind of let it be what it is and start using microservices really much more shrewdly, it seems like, not for the sake of building microservices, but shrewdly in terms of like saying, well, we want to add this service. Obviously we're not going to change our own architecture for it, but now we can do that because we can create these, we can create these different services on top of the architecture.
Right, exactly. That's exactly right. So yeah, you don't want to be doing yet another re-architecture for every new thing, but really growing into it. I mean, we're still learning as we go. About how to build effectively and starting to pull out some of these other pieces. And in particular, with new projects, that's generally obvious. Okay, now there's this new piece we want to build. We can put it over here. But there's always this, we have this kind of new thing, but a lot of it exists over here in this monolith. What is the right balance about when we're going to pull that out? And being focused on the value delivery to our customers, right?
Right.
I mean, where we choose to split lines between what's in our monolith and what's not, for the most part, is invisible to our customers, right? So ultimately, it's a decision of what's going to get us something of high quality that's actually out to the customer faster.
Right. That's interesting. So you have to make these trade-offs and decisions all the time, and what are some of the kind of the lessons that you've learned along the way that you can speak to about things that you try that at first blush looked like the right thing to do, but maybe there was a kind of a different approach? Is there anything that comes to mind in that regard?
Yeah, well, there's one of the things that I would say we learned as we moved into 2.0 was I mentioned we had monolith that was all closure, and we had found ways to, like, we have a lot of Clojure fans in the company. I'm a huge fan, but there were things that it just wasn't a great tool for it. And so as we moved to breaking things apart, that gave us an opportunity to at least try some different things. On the other hand, you can definitely take that too far, right? Like the notion of complete decoupling in microservices, I think, is really enticing. But at the same time, if everything you work on is brand new and you're always having to reevaluate and relearn new technologies just to get something off the ground, I would argue that you're focusing on the wrong thing. So finding the balance in there is really, it's an interesting ongoing struggle of, where can we get leverage? So we try to share components across services, but where can we do, how can we do that in a way that we aren't tied down or creating, downstream overhead for ourselves? I think that's going to be, I personally think that's going to be an area that probably plays out over the next few years and goes in a few circles in terms of where people are trying to draw that line. So I wouldn't say that we have a lesson learned there as much as we have just an ongoing reflection of that. And we definitely skewed very far to just everyone do whatever you want within your own service, because coupled and bounce back a little bit to, we've just done the same thing 10 times. Like, let's maybe try to find a way to get some here.
Flexibility with constraints.
Yeah, exactly.
Well, Rob, thank you so much for taking some time. We talked longer than I thought, and that means that the conversation was good. So thank you for taking some time to tell us a little bit about your infrastructure, the story behind it, your story about Nomad and Kubernetes and Docker containers and AWS, and there's about 10 other questions I would have loved to ask. So perhaps we can get together another time.
Yeah, sounds great. Thank you very much. It was really fun to chat.
Thanks, Rob. Bye-bye.
Bye.
Okay. Stop streaming.